All right, today is complex numbers day 2. And what do we do in day 2? We take the stuff we did yesterday and make it more difficult. Let's start by just reminding you what you did yesterday. Do you remember that you'd have a complex number like 2 plus 3i? And then you learned how to do the conjugate of it, for example? What was the symbol for conjugate of? Little line over it, so that would mean conjugate of. So in this case, that'd be 2 minus 3i. What happens if I times z times conjugate of z? Well, good things happen. I'd like you to actually do that. Times z times the conjugate of z. Good things happen when you do that. Now, there's a couple people not with me right now. I'm not going to say their names, but I'm going to come and check on them in a minute. Get back with me right now. You are multiplying z times conjugate of z. So here's z. There's conjugate of z. And you should have gotten first 4. Outside and inside, you should just know they cancel. You shouldn't have to think about that. You should know that. That's the point of conjugates. Then the last is negative 9i squared. The I squared part turns into negative 1. So it's 4 minus, no, 4 plus 9, 13. Raise your hand if you had 13. Okay, good. What would, when you see this, that's 2 plus I, by the way. It's not a z. Maybe I'll make it a 3 to make it really obvious. There. What to you is wrong with this? Why can't I just leave it that way? The I on the bottom can't have that. So you'd have to multiply both top and bottom by the what? The conjugate. Good enough, you don't have to do it. I just wanted to remind you that that was one of the main things from yesterday. All right. Now today is all about factoring and hardcore factoring. We're not talking about the simple stuff like x squared minus 16. That's easy. Do it, though, to warm up the brain a little bit. Dice of Destiny, who should I ask? Row 2, person 1. That's you. Perfect. Now, just to clarify, what you have there is not the answers. Those are the factors. The answers would imply this thing was set equal to 0. Normally it's y equals whatever. If I set y equal to 0, I am finding the whats. The whats are found where y equals 0. You find the whats? The x-intercepts. Okay. So if we're going to find the x-intercepts of this thing, I am finding where y equals 0, and therefore x equals 4 and x equals negative 4. And I really should have put them this way. Negative 4 here and positive 4 here. Do you get there's a big difference between a factor and the answer? Because this isn't the answer. The answer is 4 and negative 4. All right. What if I knew the answers were 2 and negative 9? What are the factors? Can you go backwards like that? Sure you can. Then the factors must have been what? X minus 2 and you say x plus 9, but I'm going to say x minus negative 9. I just want you to think about that. Did you get that? That's kind of what's really happening is I'm taking x minus both of them. It's just that when I take x minus negative 9, it's x plus 9. Why do I care? Because you can always start with x minus. Why is that important? Because what if these answers are weird? And you're like, should I put plus or minus? I don't know, because they're going to have eyes on them. They're going to have all kinds of crazy crap going on. So you have to know that you can just put x minus this and x minus that. Now let's go up a level. What would the original problem have been? Don't say it. Figure it out. What would the original problem have been that would have factored to this and then led to those answers? What would the original problem have been? Snap out of it. Start writing. Mr. AR, what do you think the original problem would have been?
Well, x squared plus 7x minus 8.
All right, and that's going to be a plus 9 there to make it clear why it's a plus 7x. All right, good job. And one more little thing, and it's kind of important. If I don't say equals 0 up here, then I wouldn't be saying equals 0 down here, and then I wouldn't have these answers of 2 and negative 9, because it needs to equal 0 to get those answers. Okay, so if you can factor it, you should. I can't factor. Or can it? And you just have this artificial assumption that it can't be factored. Well, there's a follow-up to the saying, if you can factor it, you should. If you can't factor it, you should what?
Quadratic formula.
Quadratic formula, very good. Choose quadratic formula and see what happens. And then, I want you to factor it. Use quadratic formula first. I'll pause for a second, see if you can handle it. Okay, so if I couldn't factor it the normal way, I go to quadratic formula. X equals negative b, negative 3, plus or minus the square root of b squared, 9, minus 4 times a times c. I find all the mistakes are usually made underneath that root, so watch out underneath the root. All over 2 times a, which is just 2. 4 times a times c. The a is 1 and the c is 6. And that, ooh, it makes a negative underneath the square root. What kind of an answer do I have then? Complex. Imaginary is true, but they prefer to be called complex. All right. Negative 3 plus and minus the square root of negative, what is 9 minus 24? All over 2a, which is 2. Okay? Now, can you simplify root 15 any further? Like if it was root negative 25, it would work out pretty nice, right? But so, I want to know if those are the roots, what were the factors? What could you have factored this to that you just wouldn't have seen right away, but it was actually true? Come on, somebody do this. I didn't show you the pattern well enough earlier. Yes? Nope, not plus and minus. Plus, okay. And whew, heavy duty. That's it. Now I really should have parentheses around these just to make it extra clear. Remember me showing you before that all you do is take x minus and x minus, x minus and x minus the roots. And what are the roots in this case? They're that. Now one more thing. You're not supposed to leave that negative underneath the square root in an answer. Just like you're not supposed to leave answers that have negative exponents, etc. So I really shouldn't have that negative in there. So what can I do instead? Yes? Make it I, and then it'll be regular 15. Same here. There you go. That's factored. I know it's crazy. And you could just argue that that's just not even factoring. But if you actually multiplied that out, first times the outsides times the insides times the lasts, we did it last hour. It was not even that awful. It actually works. It just takes a long time. When you actually FOIL it out, you get this. So you can factor even things that are crazy. Here's one that's less crazy. You've been told that you can't factor that, but you can. You can do it. All right, I want all of you to try it. And I will warn you, x plus 5 and x minus 5 doesn't work. X plus 5 and x plus 5 doesn't work. Gotta think outside the box. I'm going to pause for a second while you give that one a try. All right. Seem pretty logical. Should be an x and an x. Because they'll make an x squared, right? Would you agree that the numbers that are here and here probably ought to multiply to 25? Right? So there's probably a 5 involved, right? I think you might have it. What do you think?
Well, I was thinking of like doing the minus minus.
All right.
I guess that's
All right. You're right, there's not that. But at least you tried something and you figured out it didn't work. That's okay. How they invented, this is really true. Guy that invented the light bulb, and there is arguments, as there is with everything, about who was first. You know, like there's some arguments that the Wright brothers that invented flight weren't the first because there was some dude over here that says he did it before they did. Who knows? But Wright brothers got credit for first flight. Edison got credit for the first light bulb. He did try literally thousands of things before he got a light bulb to work. Tons and tons and tons of failures, and then there was something to be like, ooh, that kind of worked, and then it didn't work, and then it literally took 1,000 tries to make a light bulb work. So, if you give in, what his favorite things was, I found out another way that doesn't work. You just have to keep getting through all the ways that don't work, and then eventually you find the way that does work. Yes? Ooh, you decided to do the quadratic formula. If you can factor it, you should. If you can't factor a quadratic formula, I like it. And what happened when you did it?
I got ±5i.
Plus or minus 5i. You want to continue with that thought? Ooh, so smart. Can you just use the quadratic formula again? And even though this doesn't look like you can use a quadratic formula, you can. How are you supposed to? Well, what's the b term then in the quadratic formula then? Must be a 0, and then you got the two things, and look at that. And now, how do I know if it actually works? Multiply it out. I want everybody to multiply that puppy out, and I want you to see for yourself that it actually works. You were told you couldn't factor this before. I actually snuck in that you could factor it last year. I don't know if anybody remembered it, but I threw that in last year. So when you actually first outside, inside, last, you remember how the outside and inside always cancel each other out? And it does. So that's cool. And the firsts are just x squared, so it's really just about the lasts. What happens when you do that times that? Don't you get negative 25i squared? But then the I squared is actually what? Negative 1, which makes it x squared negative 25. Look at that. We got the original back. That must have been right. And what's cool about it is now we know the roots. The roots are negative 5i and positive 5i. How does that help? Well, because in the old days, we'd just say, you can't solve this. Think about it. If it equals 0, then do you get that would have to be negative 25? And how in the world can you square something and have it equal a negative? If you throw an I in, you're going to have an I squared in there, and that'll make it negative. Yes, sir. Yes. Yep. Even if it isn't perfect square. This always worked. X plus 7, x minus 7. That always works now if you throw in something else. X plus 7i and x minus 7i. Or if you wanted to say it this way, x minus negative 7i. You see what I'm saying? X minus and x minus, and then it's positive and a negative one. And so that ends up with this standard x minus and x minus, but it's a minus minus, which makes it a plus. Okay. But it can even work for this, which doesn't have a perfect square. Figure it out. I'm going to pause for a second while you figure that one out. All right. X plus I, x minus I is the best I can do here. I mean, I don't know how else. I know it's obviously I have an I in it. What am I missing? Something that will make a 2 somehow. So what did you put? Yes. You are correct. Root 2 and root 2. How many of you caught that? Raise your hand if you did. Cool. It's a good question. If you put the I after the square root, it just sort of looks like it's under the square root, which it never is. So it's better to put, they've got two conflicting rules. I is supposed to always be last, but nothing is, if you ever are multiplying a root, have you ever seen 2 root 5 written that way, ever? So you got two conflicting rules of math. One says the i's are supposed to be at the end. The other says that numbers in front are always supposed to be in front of a root. So in this case, the i's can go in front of the root. I wouldn't mark it wrong if you put root 5i, because you're actually trying to follow the other rule that the I is supposed to be last. I'd accept it. Yes? If you have an I under the square root, it just really messes with your head then, because you have the square root of -1. You know what I'm saying? Because isn't I equal to the square root of -1? And it's not impossible to have. It's just I can't think of a single time when you ever would have that. So, anyway, there often is an I and a root, but the I, therefore, usually just goes in front. Okay, so you have learned to factor some things you could have never factored before. But here's something you did know how to factor before, but I hope you haven't lost it. Do you remember how to factor by grouping? If you didn't know it before, you're going to learn it today. Write this one down if you haven't already. And if you remember how to factor by grouping, do it. Okay, sorry about the delay. I got stuck in a problem. All right, did you remember that that part can have an x squared come out, and then x plus 5? And that part can have a 3 come out, and then x plus 5. Raise your hand if you had that one right. Sweet. Then did you notice that they both had an x plus 5 in them? And therefore, x plus 5 comes to the front, and then I have x squared plus 3. But wait, there's more. Did you think about the last part that you just learned? And therefore, you've got x plus 5, and you've got x, what? Plus 3 root 3i, and x, what? Minus I root 3. Heavy duty. All right. Yes, sir. I get what you're saying. You feel like that should be squared because there was 2 of them. But that's not what happens when you factor something out. Let me prove it to you. 4x plus 12. Would you agree they both have a 4 in them? And I factor the 4 out to the front, and what do I have left? Do I need to have that 4 be squared? No. Now let me show you why. Because if I multiply it back in, the 4 is going to get used twice, which is kind of the whole squared idea. But if you don't put this as squared, then we shouldn't put that as squared. Okay? All right. So there it is, and that is the solutions, true or false? False. That is the what's, the factors, and it's a big difference because one of these has real solutions and the other has imaginaries. That one has a real solution, which is negative 5, and this has a imaginary solution, which is negative I root 3, and this has a imaginary solution that's positive I root 3, and that's important to get that these are the solutions. Those were just the factors. Okay. Now, one more thing. When this original problem started, I had an x to the third in it. You should be able to look at that and go, oh, so it's going to have 3 solutions. And they're either all going to be real, which means if you graphed it, it would touch the x-axis 3 times. Or it would touch with a triple root. Do you remember the triple root thing where it would go like that? Okay. Or what happens if it's got 2 reals, then it must have 1 imaginary, right? Wrong. Because imaginaries always come as a negative under a square root. And what's right in front of that square root in the quadratic formula? Plus and minus. Do you get that means there's always 2? There's always 2 imaginaries. There can't be just 1. They always come in sets of 2. I got a few examples of that. Like, for instance, deer. How many of you guys are at the point where you are driving now? All right. How many of you have almost hit a deer by now? It's usually a couple in each class. All right. Okay, so it was kind of close-ish? On your first day. Wow, that's vicious. And I don't know if the person that was driving next to you said, ooh, there's one deer. Now watch out for the next one. That's something that you should get used to, is if you see a deer, let me just make you think about in the past. How many of you have seen deer together with other deer? See what I mean? They run in packs. So kind of like teenagers at the mall. Anyway, the deer run in packs. You go and find one deer. You can bet if you look really close, there's another one like right behind it. Okay, so when they run across the road, a lot of people go, oh, cool, I just missed that deer, and then bam, they hit the second one. It happens all the time because they go in sets of 2. All right, so anyway, the deer are not like imaginary numbers, though, because they can be in sets of 3 or 4 or 5. All right, so imaginary numbers are always in sets of 2. So let me ask you this logic question. How many imaginaries could there be? on an x to the third. Could there be 3? No, they come in sets of 2. So there could either be 2 imaginaries or there's no imaginaries. So one or the other. All right. Here's a tougher one. X to the fourth. This wouldn't have been that bad if I make it a minus, but plus 16. Factor it all the way. I'll pause while you get that one a shot. Okay. Did you say x squared plus 4i and x squared minus 4i? Raise your hand if you had that one right. Okay. Are you nervous at all that I'm going to say, wait, you can factor it further? You should be. But you can't. So, if there's an I here, it would be very difficult to factor that further. Let me switch this up just a smidge and say, this one's interesting. I'm going to change that plus to a minus. You might think, well, then that's going to be really easy. Or is it? Factor that all the way. Yes. I'm going to pause for a second. Okay, did you have x plus 4 and x minus 4? Ooh, no, that would have been too easy. It was x squared plus 4 and x squared minus 4. And did you stop there? Of course not. You went further and you said this one can factor. X minus 4 and x plus 4. Then maybe this one can factor too, if you know the I trick. X plus I, 2i, sorry, these are 2's, not 4's, oopsie, plus 2 minus 2, and this is plus 2i, and this is minus 2i, or I2, either way works. Now, do you see you have 2 imaginaries and 2 reals? That adds up to a total of 4 roots. All right. One more little side thing from what I said about always having a set of 2, right? What if I say I is one of the roots? What do you know? Negative I is one of the roots. If I is one of the roots, then negative I has got to be one of the roots. And then you know the factors. If I just say I is one of the roots, then it has to follow that there has to be a pair that goes with that. And the other one, the opposite of that, would be negative I, right? So then, what was the original problem? I is one of the roots. Figure out what the original equation must have been. There's actually more than one, but what's the simplest original equation that could have existed if I is one of the roots? Well, if I was one of the roots, then negative I is one of the roots. Then you could build the factors. How many of you thought about that? X minus I and X minus negative I, also known as X minus I and X plus I, would be the roots, or the factors. If even just telling me one thing, that I was a root, then that meant all of that had to be true. And then one more thing. If I multiply that out, what would the original problem have been? X squared. Come on, you can do this. So, x squared what? Minus, you're close. You're close. Plus 1. All right. So, if the original problem was x squared plus 1, it would have factored into this, right? And so it's like we went backwards, and the answer was, all I told you was one of the roots was I. And from that, you could logically deduce that the other root had to be negative I. And then you could deduce that the factors had to be this. And then you could go back and figure out that, well, then it would have had to have been x squared plus 1. Does that make sense? All right, now use that same process. I'm going to tell you one of the roots is 2i. One of the it's just 2i. What's the simplest equation that you could have started with then? Well, then if there's going to be that whole symmetry thing of the plus and the minus, right, then the x has to equal negative 2i, must be the other one. And then the factors must be x minus 2i and x minus negative 2i, which is the same as x plus 2i. And then if I multiply that all out, it'd be x squared, and outside and inside cancel, which is cool. And then, oh yeah, I can just, I squared is going to go away, and I'm going to have plus 4. Raise your hand if you had that one right. Awesome. Okay. So now I think you are actually ready to look at the homework with me. So everybody find the homework, which is, I'll pause while I find it. Looks like this. So if you can factor it, you should. And now you just know that there's a lot more kinds that you can factor than you thought. So this top one, it doesn't factor the normal way. So what's the follow-up to if you can factor, you should? If you can't factor, quadratic formula. And then those answers from the quadratic formula can actually go back and tell you what it could have factored to. So let's use quadratic formula on this thing. And then once you're done, let's say you have x equals root 3 and x equals a negative root 3. Well, then you could know what the factors were. I'm not saying that's the answer. I'm saying figure out what the answer is from the quadratic formula, and then you'll be able to tell what its factors are. You get 1 plus and minus 2i. Awesome. That's 2 answers, right? So what were the factors? X minus and x minus. One of them's 1 plus 2i. I'm going to put it in parentheses so that negative can get distributed. And the other one's 1 minus 2i. I know it's icky, but that's what it would have factored to. If you actually simplify that down and FOIL it out, it actually will equal x squared minus 2x plus 5. Yes? To this, I factored the top. Look there. Do you see there's a 2 in both of them? Ah, there it is. Questions? So what is this nasty thing? That's what it is, factored. And you didn't, in the past you'd have to say, I can't factor that, but you actually can using complex numbers. Yes. Ooh, is there a negative mistake in there? It could be. Let me check. Would you agree with the 1 plus or minus 2i thing? Did I have that part right? I think I do. And so then it's 1 plus 2i and 1 minus 2i. And so I got that copied in here correctly. So I think I did it right. All right. This next one should be your happy place. Even though it doesn't factor like super easy, it factors. Just plain old-fashioned factoring will factor it. You just can't start with x and x. You have to start with 3x and x. All right. That's old school factoring. Ah, but what about this one? I showed you factor by grouping. But what happens if you can't factor by grouping? Because this one can't factor by grouping. Uh-oh. One more thing you have to know how to do. And that is polynomial long division. Oh, yes. So it goes like this. X to the third plus 6x squared plus 6x plus 5. You go like this, and you put and you actually have to do it. Yeah, you're going to have to know how to do this. And if it's x equals negative 5, I don't put that here. I put the factor for it, which is x what? Plus 5. Now, I know some of you are good at this and some of you aren't. I'm going to just give you a quick reminder. I'll get it started. I got to put something here on top of the little box that's going to multiply with this x here, and it has to make x to the third. I want it to match up with this first term here. So then it needs to be x squared. X squared times x makes x to the third. X squared times the 5 makes plus 5x squared. And I know you're thinking, that didn't match up. These did, but those didn't. It's okay. I don't need everything to drop out. I just need that first term to drop out. And because these are identical, they're gone. They canceled each other. And what is 6x squared minus 5x squared? Just x squared. And then I bring down the 6x. Then I think of what should I put here so that I can multiply by the x and make x squared. Looks like I need an x. Plus x. X times x, x squared. X times the 5, 5x. Remember to always go through and make them opposites. Opposite, opposite. 6x minus 5x is just x. Bring down the 5. Pretty much done it for you. But that's a reminder of polynomial long division, and yeah, you'll have to be able to do that. Problem number 33 is another good example of polynomial long division. Yes? You are correct, but I strongly recommend for the practice of it, maybe you should factor by grouping to get the answer real quick, but if you want to know if you know how to long divide with polynomials, which you'll have to for the test, I'd do number 33 with polynomial long division. Then moving on, number 47. It's the last one because we're going to skip 48 and everything after it. Okay, so I'm a reasonable person and giving you a reasonable size assignment. But number 47's kind of icky. Let's talk it through. If x equals y is one, x equals I is one of the zeros, what instantly follows from that? Negative I must also be a 0. And then what follows from that? If I and negative I are both roots, then, come on, we just did this a minute ago. You can always do x minus and x minus, right? X minus I and x minus negative I, which is really x plus I. And then, can't you multiply that out and find out that what really goes into this is something? Whatever that is, you figure it out. That's what goes out here on the outside. And then you'll be factoring x to the fourth minus 2x to the third plus 27x squared minus 2x plus 26. And that was a rough hint. I mean, it's very obscure, but we did practice it just a second ago. And then you'll figure out what to put here. And one more thing. It makes your life a lot easier if you have a placeholder. If I remember correctly, it's going to be like x squared plus 4. You can't just skip over the plain x's. X squared plus 0x plus whatever. So when you write this one, make sure that it's written with a placeholder. How many of you figured out by now that it's x squared plus 1? Is that what I'm talking about? All right. But what's the missing placeholder? 0x. Now, you can do polynomial long division for that. All right, it's some tough stuff. I know. But, all said and done, when you take the test on this stuff, it's not going to feel nearly as scary as it does today. Today's your first time through it, so it was harder. And I had to remind you of like, oh, that was probably 5 days worth of higher algebra today, plus some new stuff that you'd never done before. So, yeah, this is tough. Test won't be for at least another week. So, I'll tell you once we get close. Okay, that's all I got for you for today.